All right. So, chapter 6, study guide. Study guide. All right. So let's start with lesson 1. In lesson 1,
Do we need graph paper?
not right now. Graphs of systems. Okay? So what we learned in this first lesson was that the solution to a system of equations is an intersection. We learned that there were different ways that we could classify the solutions. Okay? We had consistent systems and inconsistent systems. Now, inconsistent systems is the easy one to remember because an inconsistent system has 0 solutions. Okay? This means that the lines are parallel. Okay? But with a consistent system, there are 2 different types of systems. First is the independent system. This is where there is 1 solution because the lines are independent from one another. They're separate. The other one is a dependent system. This is where there are infinite solutions. Okay? Infinite solutions. You do need to remember how to graph slope-intercept form and standard form. Okay? We would also use these once we got to lesson 6. I'll get there in a minute. Okay? So you should be able to look at a graph or make a graph and classify the system. Okay? 6.2. Substitution was the first algebraic method of solving a system. This is where we had a variable isolated by itself to plug into another equation. Okay? So what this may have looked like is maybe something like this. Y equals 2x plus 6. And then you had 2x minus, that's not 2x, that would not give us an answer. Let's do 3x minus y equals 8. So like this would be an example where we would use substitution. Now, what is important to remember is that when you are plugging in, you are using parentheses. Okay? On that in a minute. Okay, because like when you have this type of equation here and you're subtracting a variable, you still have to put what you're plugging in parentheses. Okay? So maybe we can put a set of parentheses there. Because especially with the subtraction, that is where you can get incorrect answers. Okay? 6.3. Here, we eliminated variables by adding or subtracting. If we had adding, it would be like the variables are opposites. Now, when I say variables, I am talking about the coefficients. Okay? the coefficients are opposites, we add. If they're the same, we subtract. Okay. Variables are the same. Okay. An example like this would be like 2x plus 3y equals 9. 2x minus 3y equals 12. Okay, so like here, in a situation like this, you could add or subtract. You could subtract to get rid of the x's. You could add to get rid of the y's. Okay, and don't forget that when you're doing something like that, you are like combining the variables. Okay. There would be times when I look at problems and people know that they are at, like, say we chose to add. They do the 3 plus -3, that disappear. But then if they saw the 2x and the 2x, they wouldn't add those together. Okay? So, yeah.
Are you saying they just put it as a 2x?
That's the mistake people will make. Yes. Yep, because when we do that, we're combining the like terms. Okay. In 6.4, we eliminate by multiplying or by multiplication. This is we multiply one equation or both equations by a number so that you get back to 6.3. Okay, so that's why we did the quiz after 6.3 instead of after 6.4, because I wanted to make sure that you knew how to eliminate by adding and subtracting before adding another step. For the most part, if you are able to do 6.3, 6.4, it's pretty straightforward. Okay. In 6.5, we were applying the different methods to solve systems. Okay, so this was really review. Okay, you are looking at the different scenarios, figuring out which method is best. On your test on Friday, what will happen is there will be some problems where I will tell you how I want you to solve it. But then there are going to be some problems where you will get to pick how to solve it. Okay. I want to know how I want to see how you add, subtract, or multiply to eliminate. I want to see how you substitute. Other problems, I want to see like how do you what are you choosing? Okay. And then 6.6, system of inequalities. This is really a review of 5.6. Okay, shading above, shading below, dotted line, solid line. Again, here, slope intercept and standard. Okay, those are what you're going to see when you solve these inequalities and graph them. Okay, and remembering that our solution is a overlap of regions. Okay. Now, there are a few general statements that we can make before I give you the problems. Okay. I'm going to go like this a little bit more. Okay. The first thing that's important to remember, we alluded to this at the beginning. In these first 5 lessons, we need to remember that the solution is an intersection. Okay? It is a intersection of the lines. Now, granted, there are those cases where you have infinite solutions or no solutions. I will say we only saw those infinite or no solutions. We only saw that in lesson 2. So the chance of you seeing something like that in lesson 3 or lesson 4 is essentially 0. Okay, we didn't even have any of those on the quiz. The other thing that's important to remember is that when you're doing lesson 2 through lesson 5, from 2 to 5, what is important to remember is you're working from 2 equations with 2 variables to 1 equation with 1 variable. Okay? When you substitute, eliminate by any of those methods, you are looking to go from 2 equations with 2 variables to 1 equation with 1 variable. And this is just everything we learned in chapter 2 about how to solve an equation, right? PEMDAS backwards. All right. So the problem, your goal should be to get at least half of these done before class tomorrow. 1 through 21 on page 383. 1 through 4. Those are the only ones you have to graph. I want you to classify the system. Those are the only instructions I'm adding. Okay. So 1 through 4, you're graphing and you're classifying them. Is it consistent independent, consistent dependent, or inconsistent? Okay. Alrighty. That's it. It is 1:58. We are getting out of here at 2:23. So you have about 25 minutes. Alrighty.